Guys, make sure that you are showing your enthusiasm in the chat section. Say hi to Rahat, and also ask your questions in the Q&A section while the session is going on. Make the most of this session. Ask or any and every question that you have for Rahat. This is a very exclusive session, and I'm hoping that everyone does derive value from it. Sirjan, I see a question about previous sessions. So the previous sessions video will be live on the Lumos Labs YouTube channel very, very soon. In the meanwhile, you can find the resources and the presentation used in the last session on the Discord server. So if you have not yet joined the Discord server, this might be a good chance. This is the QR code that you can use to join the Discord server. And there's a channel called Hackathon Resources where we've compiled all the resources that you need to build projects on all of our different tracks. So I'm also including all the resources that are shared during the sessions, if you need. Prerequisites of this session. There are no specific prerequisites of this session. This session would be a very beginner-friendly session. Am I right, Rahat? Yeah. So it's not heavily dependent on you knowing previous Web3 knowledge. I think basic fundamental knowledge would be more than enough. Anonymous attendee has asked that, can we get the recording? Yes, you will be. The recordings will be live on the YouTube channel very, very soon. All right.
Yeah, like any like code and stuff that I go over, I'm gonna actually like walk through it, so you don't have to like have any specific domain knowledge.
Mm-hmm. What do you say, Rahat? Should we begin?
Yeah, I'm ready to go.
Awesome. Hello, everyone. Good evening. Good morning, wherever you're joining us from. I am Nikhil Aprajit. I'm your host for the day in our second workshop on building a full stack dApp on Polygon. With me today, I have Rahat Chowdhury, who is a full stack developer and the lead developer relations engineer at Polygon. He's also an amazing rapper. I've seen some of his stuff on Twitter, and it would be great if you could throw us a little bit of words there at the end of the session for sure. I'd love to hear that. But anyways, today we have a session on building a full stack dApp on Polygon. And I hope you guys enjoy the session. Without any further ado, I would like to hand over the session to Rahat. Rahat, it's all yours.
Awesome. Thank you. I'll go ahead and can you allow me to share screen? Sorry.
Yeah, sorry. Yeah, can you check now?
Okay. Cool. Sharing.
Awesome. Yeah, I can see the screen.
Awesome. Great. So cool. Today we're going to be talking about full stack dApp development on Polygon. Super excited to be with you all today. This is actually like one of my favorite like workshops to give because it's really awesome to like help a lot of developers and builders like yourself like get onboarded onto Web3, especially if you're kind of like looking at it from like, you know, a newer beginner perspective. So hopefully this gives you a little bit of that grounding on like how to build in the Web3 space. A little bit of context of like what we're going to be doing today. We'll have a little bit of a couple slides. I'll introduce you to a little bit about what Polygon does. Then we'll actually do like a little bit of a live coding session where I'll code out a small smart contract just to show you like how you would like build out like your Solidity smart contracts. And then I will go over, I'm not going to live code this part, but there is a front end that goes with that smart contract that has been implemented before. I'll go through that, show that to you. But really the front end is not like, you know, a huge part of this. You know, a lot of this is like front end agnostic. You're free to use like any front end frameworks you want. In this case, I'll be using React, but I will explain any React code just in case you're not familiar. And then we'll go into kind of like how Polygon fits in the broader ecosystem. A little bit about me. Again, like I was mentioned, I'm Rahat. I'm the lead developer relations engineer over at Polygon. So my team are the folks that you'll see kind of like at these hackathons, events, virtual workshops, delivering the technical content, mentoring developers. We've got a team of 3 folks now. We've got Steph, who's also in the US, Manny, who is in Europe, and hiring for more folks. So if you're interested, let me know. Previously, I've been a front-end engineer. I've been a Solidity engineer as a contractor, and I have overall been like an indie hacker slash Web3 enthusiast. I've built a lot of failed startups, so I can't tell you how to succeed in the startup world, but I can tell you everything that did not work. So maybe that'll get you a little bit closer. These are just a few places you can find me. So first of all, about a little bit about Polygon. What exactly is it? Polygon is the leading platform for Ethereum scaling and infrastructure development. So we provide like a lot of different solutions for how you can build on top of Ethereum. If you've already been working in the Web3 space, you might be familiar with our proof of stake blockchain, which is going to be our focus for today. But we have other solutions, both in kind of like the enterprise state, as well as several rollups and solutions that are coming out very soon, and I'll briefly mention those in a bit. But like, why does it kind of exist, right? Why do we need to be scaling on top of Ethereum? If you look at like the past year or so, during like the height of the bull market, when there were like so many different NFT projects and things that were being pushed out, you'll notice that a lot of these projects are a little bit on that a lot of the times when people were interacting, there were like really high gas fees, transactions were slow, and we're going to go into a little bit about how Polygon helps fix that. So again, like I said, our focus for today is the proof of stake blockchain. We have an entire suite of different solutions. There's way more to name than I could possibly do in this one workshop. Those are like several other workshops, but one that I specifically wanted to call out that is going to be out very, very, very soon, we've announced, is our ZK EVM, which is a soon to be released ZK rollup. So if you ever wanted to dive into that, the cool thing is that everything I teach you today is fully applicable to ZK EVM. So you'll be able to use it using a lot of what I show you today, even though it's specific for proof of stake. So building on the proof of stake chain, if you've already been building on top of Ethereum, you kind of already know what you need to do. You can leverage all of the available tools that are in the Ethereum ecosystem. The Polygon proof of stake chain is what is called an EVM compatible chain. So a lot of the tools that you may have already been building, if you've already been learning Solidity, JavaScript, etc., all of these are still applicable here. And we're going to dive deeper into some of those toolings. The token that you use on this chain is Matic. Rather than using ETH, you use Matic to pay all of your fees and your interactions with the blockchain. And super accessible, approximately 10,000 times lower fees than Ethereum. And sustainable. POS chain is carbon neutral, and Polygon as a whole is going carbon negative. So we've already been like offsetting a lot of our carbon emissions. And after the merge, which happened a couple of days ago, not only did Ethereum overall go down with 99% energy usage, but the Polygon chain went even further down in energy usage. So it's super, super eco-friendly. Wanted to give you a little bit about the architecture of like how the proof of stake blockchain works under the hood. On your day-to-day, when you're developing, you don't really need to know the specifics and the deep sort of like dive into these parts, but it's good just to have a general idea. And that's kind of like what I want to give you here. So you'll see at the bottom, you have the Matic sidechain. That chain there is our proof of stake chain. That's where you'll be doing a lot of your interactions. That's where you'll be connecting to. That's where your dApps are going to be deployed to. And that is connected to two other pieces. At the top, you'll see that the root chain is the Ethereum mainnet. So everything is connected back to the Ethereum mainnet. And it's connected via this middle layer here that's called a public plasma checkpoint node. So what this does is that there's just a super fancy software computer that it's in the middle that is occasionally looking at the current state of the Matic sidechain and saving a hashed value of it to a smart contract that exists on the Ethereum mainnet. And to better conceptualize it, you could think of it kind of like when you're playing like a video game and all of a sudden there's like a save state right before a boss battle or a save point or something like that. That's essentially what's happening here. We're saving different states of data from the Matic sidechain to Ethereum mainnet so that it's backed up on the Ethereum mainnet. This transforms it from just what's called like a sidechain into what's called a commit chain, and it better inherits a lot of the security from Ethereum that way. So I mentioned that proof of stake is accessible. What did I mean by that? So I have here a contract. We're going to do a little bit more live coding in a little bit, but I wanted to just like showcase this like one little example here. So on this example, what I'm basically doing is I'm importing an ERC20 standard from OpenZeppelin. So if you're not familiar with OpenZeppelin, if you come from like the JavaScript world, it's pretty similar to like NPM, where you have different packages or different pre-written contracts that you can bring in to like shape how you build your own contracts. For example, if you're building an ERC20 token or an ERC721 NFT, there are contracts that you can use as a base to build on top of. And the reason for that is because like there are already standards that exist for like how a token should be made, how an NFT should be made, rather than rebuilding and reinventing the wheel over and over and over again, and like, you know, re-implementing transfer functions, re-implementing like reading how many people own a token. The ERC20 contract just gives you a lot of that functionality from the start, and you're just going to be using the functions that exist inside of it. And one example here is using this mint function. Rather than me just like building a mint function from scratch, why not use the standard that is accepted in the industry, given to us by OpenZeppelin, right? So all I'm doing here is just minting some initial supply of tokens. This token, this will just be in this constructor taken as an argument. So whoever deploys this contract can say, oh, I want 1,000 tokens, I want 1 billion tokens, whatever it is. They just specify the initial supply and they mint it. And that's it. Nothing fancy going on. There is no other functionality in this contract other than minting this token, and it doesn't do anything else, right? So just a couple lines of code. So this was a few months ago. So I probably have to like try this again just to get the most updated numbers. But when I was trying to deploy this on the Ethereum mainnet, I was met with this amount of gas. Converted to USD, that is $76.42. So $76.42 to deploy just a couple lines of code. If you think about it, the more lines of code, the more complexity that your smart contract has, the higher those gas fees are going to be, the more you're going to have to pay. I remember last year when I was like first learning about smart contracts and trying to build, like the very first smart contract that I built was like very poorly written, a lot of like verbose, unnecessary code in there. And when I tried to deploy it, I was trying to do that during like, I think 4 or 5 different like very high profile NFT drops. So everybody was using the Ethereum blockchain all at the same time, trying to mint all this. So gas fees were extremely high. And I think it was like $1,000+ if I wanted to actually deploy that contract. So now I'm taking this same contract and I'm trying to deploy it on Polygon mainnet, and the fee is going to be 0.0029 Matic, which is a fraction of a penny. So that's $76.42 to less than 1 cent. That's just to give you an idea of like how much more accessible it can be to build on the Polygon mainnet. So now we're going to go into the live coding portion of Bit that you have like a little bit of understanding of like why Polygon exists. We're going to be using the Remix IDE for building out our small smart contract. We're going to be doing, like I said before, a review of some pre-written code for some front-end development. I've come to realize that live coding front-end code is like not always the safest thing to do. Live coding in general isn't, but like for you guys, I'll do it. And then we'll do a demo of an existing implementation of Guestbook. So I'm going to pop into Remix. So you can head over to, if you ever wanted to like use this yourself, you can just head over to remix.ethereum.org. And this is a really good tool if you just want to like start building your own smart contract really, really quickly, and you don't want to worry about like scripts, you don't want to have to worry about local environments, and you just want to focus on the solidity. It takes a lot of that complexity of like environment, setting up your environment away from you, and lets you focus just on the smart contracts themselves. So in my contracts folder, I'm going to create a new file, and I'm going to call it sagem.sol. And I'm just going to copy a little bit of code over just to get started. So I'm just identifying like the license for this code, MIT, open source, cool, anybody can use it. I'm also specifying the version of Solidity that I actually want to use for this smart contract. Depending on the version you use, you might have certain functionality, you might not have others. So you definitely want to check in like what's available in the specific versions to see like what you need specifically for your contract. 0.8 is generally just like a good starting point. You have like a lot of access to well-tested kind of and like widely used functions, and but not maybe some of the newer, nicer ones that are not like fully like deployed, like tested, or like in a lot of contracts. So I think, at least for my opinion, at least 0.8 is probably like a safe place to start. And this little caret means that I support compilers 0.8 and above. Cool. And you'll see that I'm importing another Open Zeppelin contract. The cool thing with using a Remix IDE is like if you want to import anything from Open Zeppelin, you just drop in something like this. And under the hood, NPM, if you come from a JavaScript world, is like running and like importing everything for you. So you don't have to worry about like manually importing anything yourself. It'll just be there. And the specific contract I'm importing is ownable.sol, and ownable allows you to kind of like keep track of who is the owner of a specific smart contract. Cool. So let's start writing out this contract. So simple way to start is just declaring contract. We're going to say that this is called SayGM, and we're going to say that it is ownable. This is keyword is important. I want to make sure that I have access to all of the functions inside of ownable. So when I say is ownable, SayGM is now going to inherit all of the functionality that ownable has. And if I ever wanted to check what all of that functionality is, you can go to the Open Zeppelin documentation to do so. So I'm going to start off by giving writing a string. We're going to call it a prompt. So this is going to be a guest book. So people are going to be able to come to a website, they see some prompt, and they'll be able to answer it. So we'll say string public prompt. And here I'm just declaring a string variable. I'm saying it's public. So it's publicly available. Anyone can query this pretty easily. And we're going to say that this is called SayGM. So kind of a basic hello world type of example. Next, what we're going to do is I'm going to create so an array of answers. Or first, let's create the answers. Eventually, I want like some list of like all of the answers that someone has said to this prompt. And so first, I want to declare like, what does that answer actually look like? So I'm going to use a data structure called struct to say that this is an answer, sort of like an object or properties of like what an answer should have. An answer should have an address called from, which is going to be whoever the answer came from, as well as the actual answer itself, which is just going to be lowercase answer string. Now that I know what an answer actually looks like, I can create an array of it. So I can say answer array and call it answers. What this is doing is saying that I'm going to create an array. It's going to be an array of answer, which is referring to the struct answer. And the actual array itself is going to be called answers. So the answers array just contains some amount of answer structs inside of it. Cool. So I also want to make sure that whenever I add something to the answers, that there's some type of event or some type of something that allows my front end to understand that this has been updated. And one way you can do that is what's called with events. So we want to emit an event every time an answer is actually updated here. So I'm going to set that up here. I'm going to say that there's going to be an event called new answer. And that is going to take an address. Let's do it this way. It's going to take an address. We're going to say that it's indexed. And we're going to call that from as well. And we're just going to call the answer itself string. So basically the same arguments that are here. I use this indexed because this will allow us to index the different answers based on the address, and makes it easier to search later on if we ever needed to. Well, let's make sure I add in all of those. Awesome. I don't need that. Okay, cool. So I use like Command S to like save as well as compile. As long as you have this green check mark here, that means your code is good. So far, I've not made any mistakes. Wonderful. Cool. Next thing that I want to do is create a constructor. So our constructor probably does not have to take anything inside of it, but just so you're aware of what a constructor does inside of a smart contract, this is just code that is executed when this smart contract is deployed. In the example I showed you earlier with an ERC20 tokens, when that code was deployed, it took an argument of like the amount of tokens that we want to actually mint. In this case, we're not going to take any arguments, so I'm not going to put anything in the constructor, but it's more for your awareness that if you need to execute some code when everything is being deployed, this is where you would do it. Cool. Let's do a function called setPrompt. Just in case I ever wanted to update this prompt and get different, prompts for like answers from my people, I can do that. I'm going to say that setPrompt takes a string. It's going to keep that in memory, and we're going to call that a new prompt. This is going to be a public function, and we're going to use this only owner modifier. So what does all this mean? So string in memory just means that I don't want to save this memory in state. I just want to remember the string just for the duration of this function call. Public means, as before, anyone can access this. And then I have this only owner keyword here. I can use only owner thanks to the ownable contract up here. Only owner makes it so that only the person who has deployed this smart contract who owns it can actually be the one to interact with it. So I don't want just anybody to be able to come in and like change the prompt. I just want to be able to do it myself. And this is how I would make sure that only I could do that. So I'm just going to override the prompt. So prompt is going to be the new prompt. Cool. And then we're going to use delete answers. I don't want like answers to an old prompt to appear inside of like a new prompt. So I'm just going to clear out everything that is inside of answers. And this is a quick way to do that. This will not remove the actual answers array. It'll just remove that everything that is inside of answers. Awesome. And last thing we want to do, we'll just add in a function called answer, which actually adds something to the answer array. So that is going to take another string in memory. We'll just call this one input, which is going to be a public function. And what this is going to do is we want to push a new answer inside of this answers array. So answers is the array itself. We can use the push method available to us from arrays. And we want to push a new answer. So we have to use the capital answer to verify that this is a struct. And whenever we create a new struct, we just need to give it the two arguments that we specified, which is the address from and the string that is the answer. So in our case, we can get that quickly from message.sender as well as the input. Message.sender will automatically give you the address of whoever is currently interacting with your smart contract. And input is just going to be the input argument from up here. Well, let me make sure. Okay, of course, I have something going on. I'll check that in a second. But let's find out what I did wrong. Oh. Did not need a semicolon there. Cool. All right. So now we have a way to answer. We have a way to set our prompts. Let's also make sure we have a way to get a list of all of our answers. So as of right now, my answers array up here is not public. And if I added the public keyword here the same way I do to the string up here, I'll automatically receive a getter function for it. That solidity will just basically, give me automatically. But the problem when you have an array and make it public is that rather than give you a list of everything in the array, it only gives you one specific index that you have to specify. So because of that, we're going to create our own custom getter function, and we're going to call it function get answers. And that's going to be a public function that returns an answer in memory. And it's just going to return all of our answers.
Hey, Rahat, there was a question in the chat section asking about what does the event command do?
So yeah, event up here. We're actually going to add that back into answers in just a second. But answers, the event is really just for letting some external thing like your front end know that there was a change in state. So in this case, the event here is called new answer. So this is for tracking that a new answer was added to your state.
Understood. Understood. I hope that answers the question, whoever asked you in the chat.
Cool. So let's actually, thank you for asking that question. I'm going to add that into the answer function over here. So I have the actual push that happens, but again, I want to make sure that the emission of that event is actually happening. So after I do the push, what I can do is emit new answer. So that emit keyword is letting me say, okay, I need to say that some event happened. I really apologize for the noise. There's some construction happening outside my house. So now I want to emit this event, right? So I'm going to say I'm emitting the new answer event, and it just needs these two arguments, the address where it's from and the answer, similar to what's up here. So I'm just going to say, once again, message.sender and the input. Cool. And what did I do wrong this time? I forgot a semicolon this time. Cool. All right. So this is our pretty basic smart contract. We can set our prompt, override it. It automatically starts at say GM. The owner can override it. We can answer. Anybody from the public can answer and like push answers into this answer struct to this answer array. And we can get all of our answers as a list, right? So these are kind of like some basic functionality you would need to create your own guest book. Let's take a look at some front-end code that actually incorporates a lot of this. So I've actually gone ahead and deployed this contract before. A few ways you can deploy this. You can use Remix to deploy, and you can use a few other tools that we'll talk briefly about in a bit to deploy your contract onto a network. In my case, I deploy this onto the Polygon Mumbai test network. So if you don't want to use like actual real money to test out your applications and make sure they work, Polygon Mumbai test network is a good place to go. You can go to mumbai.polygonscan.com. And if you head over down here, you can click add Mumbai network to add it to your MetaMask wallet. And if you need funds on the test network to be able to do everything, you can go to faucet.polygon.technology and request funds here. You just drop in your wallet address and submit, and within a couple of minutes, you'll get like a small amount of tokens. But I went ahead, I already deployed this, so that's not like a huge part of this specific thing. But let's take a look at some of the front end code. So in order for your front end to be able to interact with a smart contract, one of the first things you need, of course, is the contract address. Where is it deployed? The second most important thing is this ABI. So what does the ABI look like? ABI is just this JSON object, and the JSON object basically just has a list of all of the functionality available inside of your contract. So if we look through this, we'll see things that might be familiar, like this get answers. the actual answer. And you'll see that all of the types are here, like the inputs are strings. It gives you like all of the information about these functions, the arguments, and the state variables available inside of this contract. You don't really need to care about this. You just know that it gets exported. In Remix, the way that this gets exported, if you ever wanted to like get that really quickly, is if you head to this like little Solidity icon and scroll down, there's this ABI here. You can just copy that and you'll get like a full JSON object which will look something like this. I used a different tool called Rahat to generate this, but it's the same concept. But what this is basically, if you come from like a Web 2 background, you might be familiar with like whenever we interact with an API, we need to use like a post request or something like that, or like use something like Axios or an HTTP request to actually get information or like interact with some API. That concept doesn't really exist in Web3 when you're like interacting with smart contracts. What you need is actually just what I refer to the ABI usually as is like it's a map. This is what lets JavaScript know what functions are available on the smart contract and what it can call. So to make that connection, I have a few lines of here. Most of this is copy and pasted from the Ethers.js NPM library. So that's this library here, Ethers. Really good for just like quickly setting things up if you want to make sure you're like interacting mainly with like browser wallets. So I'll go over like how to like expand that further into like mobile and hardware wallets later on. But this is taken directly from the Ethers documentation. Basically, I make an instance of Ethers. I'm requesting access to the user's wallet, so I understand who they are. This signer is essentially getting information about them. Some of that information includes their address. And to actually connect to the contract that I have, I need to provide the contract address, which I have saved up here, the ABI, which I mentioned before, and the signer, which is the person who is currently trying to interact with this contract. As long as I provide all three of these details, I can make a connection to my contract, and I have access to all of these functions: set prompt, answer, get answers. And to see kind of like that code being handled in here, we have this GM form. But you'll see, essentially, I have my contract, right, that I'm passing down the functions from the top level component. And I have access to the answer functionality, which we wrote down right here. So that's this function directly from my front end code. And you'll see like throughout, I can get the prompt, I can get answers, all of that available right through my front end. Again, I'm not going to focus more on the front end because the front end, you can use any front end you like. You can use React, you can use regular HTML, CSS, and JavaScript. You can use Vue. That's not really the focus of this, I guess, overall lecture. This is really just to show you that, this is possible how you would do it in React using the Ethers.js library. And I believe Ethers.js can be used in a lot of different JavaScript frameworks. So this is more like on the JavaScript front end side. Let's take a look at the actual application itself. So this is when you first actually go onto the application, you can connect your wallet. I hit the connect wallet button. It was very quick because I've already connected before, but if this is the first time that you were to connect, then your MetaMask wallet would pop up to give you, some, information. So this, like I said, is an implementation that I've written before. I did a little GM Buidl for Web3 for all y'all. And if I wanted to, let's say, add a new one, here is a new answer. I hit say GM. You'll see MetaMask pops up. I pay some small amount of gas, hit confirm. And, sorry, I accidentally refreshed. It's taking a little time. Let's see, is the trend transaction still pending? Okay, there we go. Here's a new answer is now here. and it came from my address, which is great. Cool. So all is set up. This is like the list of all of the different answers that have been given being displayed using that from address, as well as the actual string that is from the message supplied, which is what we see over here for the function answers. So this is like that, and this is the array of answers with the struct containing all of the answers inside of it. Awesome. So that was a quick implementation of live coding a full stack guest book. And really, like I said, that's just, this was a very, very quick implementation. A lot of it is not, completed code. Again, because I don't have, a few hours to actually show you how to give you a full implementation of code, but it's really meant to show you that, you write your smart contracts, you query it using this ABI, using some library on the front end. Ethers.js is one of those, and we're going to dive into some more of those now. So I showed you some bare bones tools, but if you want to build real robust decentralized application, requires using a combination of tools in the ecosystem. So what are those tools? So for smart contract development, I showed you the whole time that I was using Remix. But if you want more power and control over your environment, if you want to build your own scripts for deploying, for testing, etc., you would use one of these different packages. You'd use something like Rahat, Truffle, Brownie, and Foundry. So Rahat and Truffle are for those of you who might be more familiar with JavaScript and want to use your JavaScript, scripts. If you want to start testing your Solidity code, that can be done using JavaScript. Rahat and Truffle are probably good, tools to look into. And what they do is they help you set up your local environment so you can code this on your machine rather than doing this on Remix. Brownie is for folks who are more familiar with Python. So if you come from a background in Python, definitely recommend Brownie. Foundry is a little bit newer. It's it's a Rust-based tool. You don't actually need to know any Rust to use it. But the cool thing with Foundry is everything basically is done in Solidity. So if you don't want to deal with JavaScript, you don't want to deal with Python, you just want to really focus on the Solidity, Foundry is a good option there. Some front-end tools. I showed you using Ethers.js. Now, the issue with using only something like Ethers.js is that it doesn't help you very easily connect to different types of wallets. It doesn't help you, you would have to create your own UIs. You saw my UI was very bare bones. There was no good feedback given to the user that some transaction was happening, that their wallet was connected, etc. A lot of that UI I would have to manually build myself. So rather than just using Ethers.js, there's a lot of other front-end tools that help you do a lot of that UI work right out of the box very quickly. One of my favorite ones is Rainbow Kit. Rainbow Kit is actually built on top of this WagMe hooks package. So WagMe hooks is pretty React specific. It gives you a bunch of React hooks that allow you to quickly access an address, quickly connect to a smart contract. So you don't have to do all of that boilerplate code that I did in my implementation, so that you can use these composable and reusable functions for doing a lot of these, things that you have to do over and over again. And WagMe hooks is also actually built around Ethers.js. So Ethers.js is the base, and all of these abstractions built around it make it easier and easier for you to actually build. I believe WagMe hooks right now is React specific, but in the future, it's going to be framework agnostic. So you can use it in any framework you want. And the other thing I'll shout out is Wallet Connect. Wallet Connect is also baked into Rainbow Kit. So if you use Rainbow Kit, you have Wallet Connect already in there. But Wallet Connect allows you to not only connect to someone who's using a MetaMask wallet, but let's say someone who has a mobile wallet. Maybe somebody has a hardware wallet. You want to make sure that your dApps are being built so that all of these different types of users can actually use it. So these are good packages to look into to make sure that you're being as accessible as possible to these different types of folks. And while this might be kind of outside of the scope of this hackathon, but if you go and take your MVP and you want to really put it into production, I definitely recommend looking at security and analysis tools like Slither and Mithril. It'll help you identify some like potential security issues in your code. They're not 100% accurate. They're kind of like, will give you some suggestions. So definitely keep that in mind as you're building, if you're looking at the security side of things. If you ever want to go into production, these are not a replacement for like an actual security audit. This is just like kind of like the first step before you go into like a security audit. So before going into production, you always want to make sure, especially if you're building in something like in the DeFi world, that things are audited by a professional. So we talked a little bit about reading data, and I read data using just like the Ethers.js library. But another really good tool for like reading data is the graph. So the graph makes it a little bit easier by giving you what are called subgraphs that essentially index a lot of the data that exists on the smart contracts on the blockchain, so that you don't have to, like, if you look at this implementation I had to write this whole function out of like get answers, right? What if you had like a bigger application? Do you want to have like a getter function for every single type of data? No, that would suck, having to like, write all of that. So what the graph does is like they actually index a lot of that data that exists on smart contracts and make it easier for you to just query and read data using GraphQL. So if you're familiar with GraphQL, this is a really good tool to use and to query information very quickly rather than building out your own getter functions over and over again. Now, going beyond that, going beyond reading and writing, eventually as you're building out dApps, you're going to need some type of file storage. Some cool storage options are using things like Filecoin and Arweave. Both of these great solutions. Definitely take a look into them. You essentially save, you can save images, videos, JSON data, anything like that, onto either the Filecoin or Arweave blockchains and interact and use them that way. And if you want to take that even further, another really cool tool that I like telling people about is Lit Protocol, which is decentralized access control for Web3. So let's say you have, different images, different videos, but you want to like gate them. Maybe you want to token gate them in some way so that only specific people have access. Lit Protocol is something that can like help you kind of like do things in that direction. And then, eventually, you might have some off-chain data protocols, which are really cool. Ceramic and ThreadDB. Not everything can always, be saved to a smart contract. That can get very expensive, even on something like Polygon. Some data maybe doesn't need to live on the blockchain. Maybe you have data about certain profiles or users. These are good ways to like add, that type of data, like versus adding like a traditional database into your dApps. And this is not really a complete list. I can go on and on and on about all of the different Web3 tools that exist that you can use, like build on top of Polygon with. But these are just like some of the tools that I like kind of like in the ecosystem that can help you build out, more complex applications. And the thing to really note is that, Web3 protocols, they're your building blocks. You have to use them together to build. I was just building a very basic implementation, but like you might want to build something, beyond just, a GIS book. You might need file storage. You might need to read more data more quickly and easily. You might need to have like some off-chain data. These are the different ways to like make your apps more robust and more usable for your customers. And what I really want to kind of like show you now is the cherry on top. This part is a little bit more complex than the rest of the overall workshop, but it's something that I definitely recommend looking into if like maybe as you like go on past your initial projects and want to like build it out further. Using Polygon to supercharge your dApp's UX. I want to talk to you about something called gasless meta transactions. So during this whole interaction that I just showed you, if I wanted to like go in here and add a new prompt, like new prompt or whatever, and I hit say GM, my MetaMask pops up. I have to pay some small amount of Matic, right? And at the end of the day, this is a very, very, very tiny amount of Matic. It's like it's less than a penny, right? But still, it's not the best user experience, right? Especially for somebody who comes in and they've never used Web3 before. They've never minted a transaction for it. They want to just try out your application. One big friction point that you'll get, especially if you're trying to build a product for like real customers, is that, if they're new to Web3, then, they might be like, oh, why do I have to go and load up my wallet with money? I don't want to do that, right? It's just an extra step that people have to do to use your app. So how do we eliminate that step? These are, again, things that I recommend like reading further into, but I'm going to give you a high level overview of them. We have something called EIP 712, which is an Ethereum improvement proposal. Definitely recommend checking out Ethereum improvement proposals to see like a lot of the different ideas that people have for implementing new features and things. And you might even get like a lot of ideas like implemented to your own apps from there. But this is an EIP that is around structured signed data. And we're going to go and break that down a little bit further in a second. But essentially what happens is on my front end, maybe I'd collect some data from a form like that say GM form. And instead of like creating like and activating a transaction, I just tell MetaMask, hey, just like make sure that this person is who they say they are. Let's like verify that they are the owner of this wallet. Great. We verified that and we take some data. We take that data, structure it inside of like a JSON object, and we make like an HTTP request to some endpoint, right? So this is back in Web 2 world. We send that endpoint can belong to something called a relayer. That relayer can be in some service like OpenZeppelin Defender or Biconomy. And what that relayer does is that it's waiting for you to send some request about this signed structured data. And what it does, it takes that request, it loads in the gas for that request and executes a transaction to your contract. So now I can go into my say GM, and instead of me paying the gas, like I just signed the transaction to make sure that, hey, yes, this is me. And now my relayer is going to pay the gas for me. It sends the transaction with the gas paid on behalf of the user to the contract executes and sends the information back to the user. So if you were looking at like doing like an NFT minting, right? What if you wanted to make a completely free mint without gas, without anything? This is kind of like how you would do it. So let's break down EIP 712 a little bit more. It operates on this like don't trust but verify. Like I said, it's going to open up your MetaMask and verify that, you have to click here. You have to understand like what data you're sending to this endpoint. But it designs a data structure for your signature. So you can just create that in your front end. It could be some JSON object with some information. Maybe it's the information in our answers. That information could be our answer as well as the address of the person currently interacting. If you're using ethers, the method to actually do this is called signed type data. And that's going to actually open up your MetaMask and verify the signature for you and allow you to save that. And then from your JavaScript front end, you just create the signature and send it to the HTTP endpoint. Using the actual relayer, you set that up beforehand. You set up your relayer and you load it up with a certain amount of funds to cover the gas for your user. So you have to preload it. So nothing in life is free. You still have to pay for the gas. You just pay for it upfront for the user. So you load it with gas. There's also different grants available from places like Biconomy if you wanted to like get a grant for doing gasless transactions. And we're just making requests to some endpoints applied to us by this relayer. We set up the money, we set up which contract it needs to interact with, and we make the request. And if you want to see like a really, really good example of this out like in production right now, check out Lens Protocol. Lens Protocol is a composable kind of like social media building tool. where like there's a lot of social media projects that are built on top of Lens. And if you use Lens's API, everything is saved to the Polygon blockchain, but you pay no gas at any point ever because they're using this EIP 712 and this relayer to pay the gas for you. So definitely check out Lens protocol to get a good, like really awesome implementation of that. And overall, this is going to improve the UX of your overall application. So highly recommend diving deeper into it. And this is economically viable in Polygon, right? If you were to like load up gas on the Ethereum mainnet, even after the merge, you're gonna like the merge really didn't do much to lower gas prices. So you're going to be spending a lot of money very quickly. And you can do this like for specific use cases. Maybe you want to use this for like new customers, like let them do like a try before you buy, to like give them kind of like a 30-day free trial or something like that. This is how you can implement something like that. But yeah, just to kind of like wrap it up, again, I'm Rahat, developer relations engineer over at Polygon. If you enjoyed this workshop, have any questions, you can feel free to reach out to me, tag me on Twitter at RahatCo. It's always happy to figure out how I can help in any way. Thank you.
Hey, Rahat. So we have a few questions in the Q&A tab.
Cool.
So the number one question that was kind of asked in the very starting of the question, Swagata is asking whether could you go over the layer 2 architecture which makes the transaction faster? I think this is a much more deep question to cover with the limitation of time. So
yeah, that would definitely be a little bit deeper dive. I can definitely drop some documentation that goes into
the
like
chat is also asking that if you could share like the resources in the chat section, like the faucet link and the testnet link and everything, if you could share them. That, and I think we'll also share it in the Discord server after the session. So if anyone misses it here, they can definitely check out the Discord server. We have one more question. Tarun is asking whether Polygon and the technology in the backend can be embedded in Flutter. Can they use the framework Flutter to build projects?
I believe so. I'm not really a Flutter developer, so I can't say per se, but I believe there should be some tools to help you. Essentially, as long as there is some tool in Flutter that allows you to interact with EVM blockchains, then the answer is yes. I don't know specifically what those are. You just have to look at like the Flutter ecosystem to see if those tools exist.
Got it. There's one more question. Web3.js or Ether.js or UseDApp, which one to use for connecting wallet and contract?
So I would use none of them. I would actually use some higher abstraction like WAGMI hooks and Rainbow Kit, because using any of those are going to make you have to do a lot more work with like doing connections with like a wider variety of users. Whereas like using an abstraction like WAGMI hooks and Rainbow Kit, you can target tons of different types of users all at once without having to do a lot of heavy lifting. So the implementation I used was using Ethers.js, and there was like a ton of code there, but I could only really interact with people who had like a MetaMask wallet, right? So you're going to be very limited using anything like that. I don't know too much about the third one that you mentioned. I think it was UseDApp, right? I can't really say much. I've never used that. But Ethers.js and Web3.js are like kind of like really basic tools. But a lot of like the abstractions are built around Ethers.js. So I tend to like recommend Ethers.js just because a lot of tools are built around it.
Got it. So Ashutosh Yadav did ask in the chat while you were demonstrating that, can you please tell me what to install in order to run the front end? I mean, packages. I think he meant to ask about what kind of packages do you need to run?
Yeah, on the front end, it was React. So like a basic React application, you can use like a create React app. There's nothing fancy like there. It's just like the basic React scaffolding. And the only real package I installed was Ethers.js.
Understood. There is a question by Swagata. Is it focused on any single mainnet? But I'm not understanding the context of the question. So Swagata, if you could drop in the chat what the context of the question was, I think we can take in it that as the last question. And we can conclude the session. I don't think Swagata is there. Anywho, folks, this is the link to the Discord server. If you've not yet joined and become a part of the community, all the resources that have been used in this session will be shared with you. The recording and the YouTube link also will be shared there. Also, any updates related to the hackathon will be shared on that. If you have not yet joined the server, I think this is a great chance. Go ahead, scan the QR. I'm also dropping in the link in the chat. Okay, what differs Polygon with other blockchain protocols like ICP? I think that was the question.
Okay. I'm not familiar with
I think
ICP.
ICP, with that they mean Internet Computer Protocol, the definitely.
Okay. Gotcha. Yeah, I mean, I'm not familiar with like the overall architecture of ICP, so I can't really speak to like the technology. For Polygon, like the main things that we kind of like really focus on, at least on the proof of stake chain that I like spoke about today, that's just like one of our solutions. We kind of like focus on like providing a lot of different solutions for different use cases. So proof of stake is like a place where you might start building to like take advantage of like lower gas fees and faster transactions. And then for further scaling, further privacy, we have like enterprise level solutions as well as like private blockchains, creating your own blockchains that are, kind of like outside the scope of this workshop. So I would kind of like look at it as like the overall different solutions we have. We have different solutions for specific use cases. So kind of like looking at Polygon being like a Swiss Army knife, you choose like what you want to use for your dApp.
I think that's a perfect analogy to sum up what Polygon can do, a Swiss Army knife. One tool for almost every solution, so every problem. But thank you so much, Rahat, for taking out the time and doing this workshop. I'm sure that our attendees have today gained invaluable insight into the Polygon blockchain and have also gained inspiration on what they want to build on their projects in the Build for Web3 hackathon. Guys, again, I would remind you, if you've not yet registered, go on hack.lumoslabs.co and register for the hackathon. Make sure that you build on the Polygon track because we have track special prizes as well. So if you want any other help, do reach out to me on Discord, or you can reach out to Rahat also on his Twitter. With that, thank you so much, everyone, for joining. See you on the next workshop. Bye-bye for now.
Bye, all.